Okay, so let me do question number 99 on worksheet 10.7 on buffers. And it says, how much solid sodium acetate trihydrate must be added to 0.300 liters of a 0.50 molar acetic acid solution to give a buffer with a pH of 7. Hint, assume negligible volume change when the solid is added. So my equation is going to be acetic acid is going to dissociate in water to give me acetate and hydrogen ions. That's the R of my rice. So now I'm going to do my rice table, and it says that I have 0.50 molar here, and I'm going to add some amount of this X here, so that's going to be at equilibrium. What is this X going to be? And I want to have a pH equal to 5.00. So if on my calculator I do 10 to the negative 5.00, that will give me the hydrogen ion concentration. So I'm going to take second there and put in negative 5.00 equals, and I get 1.0 times 10 to the negative 5. But since this had 2 decimal places, I need 2 significant figures times 10 to the negative 5 molar here. Now the other thing I need to know is the Ka of acetic acid. And if you've done enough of these problems, you get to where you memorize some of these, and that's 1.8 times 10 to the negative 5th. It's also listed for you in question number 89. So this is going to be 0.50 minus x, but we're going to assume that x is much, much smaller than 0.50 because this exponent is so small. That's a good assumption, so I can ignore x. And so my Ka is going to equal my acetate anion times my hydrogen ion. Oh, and I don't need that 10, divided by my molarity of my acetic acid, and that's all going to equal 1.8 times 10 to the negative 5th. So I'm solving for x. So I'm going to take 1.8 second e negative 5th. I'm going to multiply that by 0.5, and I'm going to divide by 1 second e negative 5 equals, and I get that x is going to equal 9.0 times 10 to the negative 1, which is 0.90 molar is what I need to make. Now, in that question, it tells me that I have my volume equals 0.300 liters. I'm assuming there's no change in volume, so molarity equals moles divided by liters. So molarity times liters will give me my moles. So that's going to equal 0.300 liters times 0.90 molar, and that's going to equal 0.3 times 0.9 equals 2.7 times 10 to the negative 1. Let me get this out of scientific notation. It's 0.27 moles that I need of sodium acetate trihydrate. Now I have to figure out the molar mass of sodium acetate trihydrate. So I have carbon, hydrogen, oxygen. I have 2 of those. I have 4 of those, and I have 2 of those. And then for water, I have 2 more, and oxygen, I have 1, but I have a trihydrate, so I have to multiply each of those by 3. And so, doing the math, 2 times 12.01 plus 4 times 1.008 plus, oh wait, oh, nope, I messed up. That should be a 3, and I need a sodium, and sodium is 22.99. So let me start over. 2 times 12.01 plus 3 times 1.008 plus 2 times 16 plus 6 times 1.008 plus 3 times 16 plus 1 times 22.99 gives me a molar mass for CH3COO Na. Make sure it's Na. Yep. Trihydrate. Molar mass is equal to 112 wait, I made a mistake. 12.01 times 2 plus 3 times 1.008 plus 2 times 16 plus 6 times 1.008 plus 3 times 16 plus 22.99 equals, 137.066, and that's grams per mole. So that's how many moles I need. So I have 0.27 CH3COO Na. I have for 1 mole, it's 137.066 grams. And so times 0.27 equals, I would have to add 37 grams of NaCH3COO dot 3H2O. So let's kind of summarize the steps here. First, we need rice. And after we do rice, what are we going to do? After rice, we're going to calculate the hydrogen ion concentration by saying 10 to the negative pH equals the hydrogen ion concentration. And that's going to go into our equilibrium expression. Then once we have we will calculate the molarity of the conjugate. In this case, it was conjugate base because we had an acid. Then after we calculate the molarity, we're going to go from molarity into moles of that conjugate base. After we get to the moles of the conjugate base, we're going to go to grams of that conjugate base. And to do that, we use the molar mass. So I'll do another video with number 100, and then I have a couple more to do. So thanks for listening.